Good day. How are you doing today? So in this lesson, I'm going to show you how to determine the stationary points and their nature. But before we dive into it, what are the stationary points? So the stationary point on a curve, this is a point at which the gradient of the curve is equal to 0. Like on this parabola, which has got a maximum point, the gradient at this maximum point is equal to 0. Therefore, this point is a stationary point. And similarly, on the minimum graph, if you find the gradient of the minimum point, that will be equal to 0, and that is also a stationary point. So just to describe these graphs, you see from this part going up, it's like you're going up the mountain. Therefore, the gradient on that side, the dy dx, is positive. So it's greater than 0 because you are increasing in gradient. Whereas here, it's actually a negative gradient because you are going down. So your dy dx is less than 0. So the same applies for this graph. So it's like you're going down into the valley, and when you reach the bottom, it's actually easier to go down. Therefore, your dy dx in this part is less than 0. And whereas when you're going up, that is your dy dx will be greater than 0. So the gradient is positive here. So in simple terms, remember, the stationary points, these are points at which the gradient is equal to 0. So you don't only get stationary points on the parabola, you also get stationary points on your cubic functions. Cubic functions are actually one of the interesting functions because you tend to get a maximum sometimes and a minimum point. So just for example, if we have got our cubic function here, and you can see the point at which the graph is maximum, that is m is equal to 0, that at that point, that is a stationary point as well. And you've got a minimum point here, which m is equal to 0, and also that is also a stationary point. So this is interesting because you've got actually two stationary points, which is a maximum point and a minimum point. You also have another point of stationary, which is the point of inflection. So this point of inflection, it is a point whereby the graph changes from being concave down to concave up. So that is also a stationary point. So without wasting time, let's get into some examples. So in example 1, we are saying find the stationary point of f of x is equal to x squared minus 2x plus 5 and determine their nature. So the first thing that you want to do before you actually determine the nature, you want to find the stationary point. So remember we said at the stationary point, dy dx is equal to 0. So in this case, we can actually say first derivative of x is equal to 0 because we are dealing with f of x. So then we find the first derivative of x, that will be equal to 2x minus 2. And we equate this to 0 because at a stationary point, the first derivative is equal to 0. So 0 is equal to 2x minus 2, and x will be equal to 1. So at this stationary point, x is equal to 1. So to get the y-coordinate, we substitute this into the original equation, and we get f of x will be equal to 1 squared minus 2 times 1 plus 5. And that gives us 1 minus 2 plus 5, and that gives us a 4. So which means the point, the stationary point on this graph, it's 1, 4. This equation, it's actually very easy because we know that this is a parabola. So for the parabola, it's easy to determine the nature of the stationary point. We know that this curve, because of the coefficient of x being positive, it's a 1. Therefore, this graph will automatically have a minimum point. But we need to determine this algebraically so that you know how to do it when you're doing it cubic functions or polynomials. So to determine the nature of the stationary point, what you do, you need first of all to determine the second derivative of function. So if you get the second derivative of a function being greater than 0, you have got a minimum point. And if the second derivative is less than 0, then you've got a maximum point. So in this case, we find the second derivative from this. This is the first derivative. So the second derivative will be equal to 2. And comparing that to this here, which means that the second derivative is actually greater than 0. Therefore, we have got a minimum point. That's how you do it. Then in the second example, find the coordinates of the stationary points of the cubic function x cubed minus 5x squared plus 3x plus 1 and determine their nature. So the same principles apply. Remember, the first derivative is equal to 0 at the stationary point. So we find the first derivative of this function, that will be equal to 3x squared minus 10x plus a 3. That will be your first derivative. Then, after you have done this, you want to solve that quadratic equation, equating it to 0. So 0 is equal to 3x squared minus 10x plus a 3. And if you factorize that, that will give you 3x minus 1 in a bracket x and a minus 3. And your x value will be equal to a third or a 3. So after you get your x coordinates, you can actually determine your y coordinates. Remember, by substituting into the original equation. So if you substitute that 1/3, you get your y as equal to 40 over 27. And when you substitute your 3, you get your y coordinate is equal to a 10. So the coordinates are a third and 40 over 27 and 3 and a 10. So we have got now the stationary points. So we want to determine their nature. Remember, to determine the nature, we find the second derivative. There, the second derivative of this function will now be equal to 6x minus 10. So now what we do, we just substitute the x coordinate into the second derivative. If the second derivative is greater than 0, then we have got a minimum point. And if it's less than 0, then we have got a maximum point. So if we substitute a third, that will give us the second derivative being equal to 6 multiplied by a third minus 10. And that is equal to negative 8. Remember now, the second derivative is less than 0. So which means we have got a maximum point. Then if we substitute the value of 3, we have 6 by 3 minus 10, and that will be equal to 8. Therefore, we've got a positive value, which means we've got a minimum point. So this is a minimum point, and the other one is a maximum point. And that's how you determine the nature of the turning points. I hope that makes sense. See you in the next lesson.